All right, guys, in this video, we are going to continue with this section, the last little bit of the 5.6 stuff, which is really focusing on like change in tandem along with like some rates of change and stuff. And we'll just kind of see how far we get in this video. It's possible we'll need another one, just depends on how long this is taking to get through. So anyways, we have example 2. Now, the last video I went through and I explained how we can kind of change or go back and forth between reading like a polar graph versus a rectangular graph, and how we can see the positive and negative, increasing, decreasing function stuff for that. Also talking about your R value getting like further from the origin, so increasing versus decreasing. Anyways, we're gonna answer a question here. It says AP tip. So for those of y'all who are AP, may make note of this. It's often helpful to sketch a graph of a given function in rectangular coordinates. That's kind of the whole reason we did the last video, in order to help describe the behavior of a polar function. So you're seeing here an example 2. They said, consider the graph of the polar function. They gave us an equation in the polar coordinate system. Which of the following statements is true about the distance between the point with polar coordinates and the origin? So we want to know, is that distance getting more? Is it getting less? So is it increasing or decreasing? On what interval? And what would be the reason why it is doing that? So the first thing is I'm going to follow that tip because I think that's going to be the easiest way to go about this problem. And I'm going to change my polar equation here into rectangular. So we're just going to say y equals 2 minus 4 cosine x instead. Now, if you prefer, I know some of y'all prefer to see it in this order instead. That's totally fine. That might make it more clear to you what's going on with it. So totally feel free to do that. But we're going to sketch a little graph of this guy and then see what we can do about it. So okay. I want you to notice that these intervals, I'm seeing stuff that goes as far out as 2 pi. So I'm going to go ahead and draw this out to 2 pi. The period of this function is going to be 2 pi anyways. It's not been changed. And the period of cosine is 2 pi. So makes it simple. All right. So then these are going to be our little intervals of little breaking it up so we can see where our extrema are, our zeros, and all that jazz. So it'd be 3 pi over 2. All right. Now, as far as our y-axis is concerned, we got to talk about this guy. So this y-axis, we're going to need to figure out how to scale it exactly. Now, one thing that I know is I do know that this has been moved up. I also know that it's got an amplitude, there's a word, of 4, and it's been reflected. So there's a lot going on here. But just keep in mind that we can piece that together. You think of what the typical cosine function looks like, and it hits the extrema on the y-axis. This one is going to hit its minimum on the y-axis. Okay. And it's also been moved up to. So we have to think of and it's been stretched by 4. So as far as the way it's going to look is typically I would have thought of this. If I just saw the negative 4 cosine x, I would have said, okay, well, this is hitting its minimum of 4 on the y-axis. So down at negative 4 on the y-axis. But the problem is it's been moved up to. So instead of hitting at negative 4, we're going to hit that minimum at negative 2 on that y-axis. Okay. All right. Now we also know because our amplitude is 4, our midline is going to be right in here. And y'all, your picture does not have to look perfect, but it should look good enough to be able to read it and understand it. All right. And then the other side, 1, 2, 3, 4. Again, I can't draw very well, but it's fine. Okay, so whenever we see this thing go through this period of 2 pi, what we know is we know that halfway through the period, it's going to hit its maximum. It's going to come back down and hit that minimum again. Halfway between here, it's going to hit the midline. Okay, so you can kind of use that to your advantage and just sketch. Again, my drawing skills are not the best in the world, but there we go. We got somewhat of a picture. Okay, enough to be able to answer the question, right? That's really what's important here. So we're looking at the problem. They said that we're looking at the distance of the or the distance is increasing. Now, here's what I want you to remember. One more thing, and then we should be good. Do you remember how I told you guys in the last video that when this rectangular graph is getting closer to the x-axis, the polar graph is getting closer to the origin, right? So this x-axis is kind of like, it's equivalent to the origin, to polar origin. So when they ask me if the distance is increasing or decreasing, what we're saying is it getting closer to the origin or further away? So here, is it getting closer to the x-axis or further away? Okay. So here we said the distance is increasing from pi to 5 pi over 3. Pi is here. 5 pi over 3 is over here where this thing crosses. Okay. So that's giving you that little breaking point. So is the distance increasing here? No, because it's getting closer to the x-axis, meaning that it's getting closer to the origin. The distance is decreasing. So no, that doesn't make sense there. The next one says the distance is increasing from 5 pi over 3 to 2 pi. Well, 5 pi over 3 to 2 pi. Yes, the distance is increasing because it is getting further away. But let's look at our stuff. So that first bit is true. They said because f is negative here because it's below the x-axis, and then increasing. F is not increasing here, it is going down. So that is not true. So this one's not true. Neither one of those is good. Okay. All right. C, they said the distance is decreasing on pi to 5 pi over 3. So again, pi to 5 pi over 3. The distance is in fact decreasing because it is getting closer. Then we see, okay, so we've got that part. Then they said because the function is positive, that's true. It is above the x-axis. And decreasing, that's true as well. It's going down. All parts of that line were true, so that is true. You could check the last one, but we have our answer. Okay, so got that one done? Awesome. Let's go to the next one. Now, this next one provides us with a rectangular graph, so that's a little different. Keep in mind, again, this is the equivalent to the polar origin, right? So we're going to keep that idea going. All right, the question says, let's see if I can get the whole thing on here. The question says the graph of our function is shown on the rectangular coordinate system if the polar function, basically the same thing in polar coordinates, on which of the following intervals is the distance between the point and the polar coordinates of the origin decreasing? So we should be looking at where is the distance getting less? Where is it getting closer to the origin, right? So this one's already kind of set up for us. You see this interval here is saying from 0 to pi over 4. Well, let's look at that. From 0 to pi over 4, the graph is increasing. They want us to see the origin decreasing. So we need to see if it's getting closer to the x-axis. From 0 to pi over 4, that's not happening, okay? It's getting further away. If you look at the next one, pi over 2 to 3 pi over 4. So pi over 2 is here to 3 pi over 4, which is here. That is getting further away. We want it to be getting closer if the distance is decreasing. The next one is 3 pi over 4 here to pi here. That one is getting closer to the x-axis, meaning that is the one that has that distance decreasing. You can check the last one, pi to 5 pi over 4. That's getting further away, so that's not it either, right? Pick the one where it's getting closer. Okay. Let's talk about relative extrema. All right, now this is going to be an AP question. I'm going to say on level, I wouldn't bother with this one. I'm going to let this just specifically be for AP. So if you are on level, try to skip ahead. Actually, I would say just let this video be, or let this video be done for you if you are on level, because I'll make a separate video to start the next topic, okay? All right, so here we've got relative extrema and polar functions. So we have this thing that says another characteristic arises when we study polar functions. Our relative extrema for polar functions, r equals f of theta changes from increasing and decreasing or from decreasing to increasing, then the function has relative extremum on the interval corresponding to a point relatively close to the furthest from the origin. Oh my gosh, that is a mouthful of words, right? But essentially, they're trying to help us to understand when we see this thing changing from increasing to decreasing or decreasing to increasing. And I would really encourage you guys to still sketch a picture of the rectangular version of this so that you're able to answer the questions a little bit easier. Okay, that is my number one tip on things like this. So what I'm going to do is I'm going to say, let's make a little sketch of the graph. We're going to put it as y equals negative 2 sine of 2 theta plus 1. Now this will affect the period because you see a value that's multiplied in here with that theta. So you got to watch out for that, okay? Period, that we can calculate with the equation 2 pi divided by b. So if your b value is 2, right, then this is 2 pi divided by 2, and that's just pi. So I know that for my graph, when I'm sketching this out, I know I should only draw it out to pi, okay? All right, we're going to sketch this guy. Again, only making this go out to pi, but we still end up having to break this up. So halfway between, and that's going to be pi over 2. Halfway between these two is pi over 4. Halfway between these two is 3 pi over 4. Sine typically starts at the origin. However, this one has been moved up. So we're going to move this up 1. Okay. And then we're going to also open down because it is negative. We also see that our amplitude is 2. So make sure that you're going down 2 steps to get to each extremum. Okay. All right. So we are going to open down because it was negative. Okay. I'm going to land back up here. I'm going to go up here and there. Okay, that's what I'm seeing there, just drawing out one period of it. And that's really all I need to draw because you see these intervals, everything is no more than pi, all right? All right, let's go through our choices here, see if we can figure this out. So maybe if you see how they've got this thing broken up, they've got it looking at these pi over 3s and 2 pi over 3s. You're going to want to know where those exist. So just, keep that in mind. Pi over 3 is a little bit more than pi over 4. So if I was looking at over here, actually, yeah, it's around in there. And then if I was looking at 2 pi over 3, we're looking at kind of similar idea, but on the other side. And is that, yeah, that's fine. Okay. So those little blue marks will indicate my little pi over 3 intervals. Okay, so they had said here, the graph has a relative minimum on the interval pi over 3 to 2 pi over 3. So pi over 3 to 2 pi over 3. Do we have a minimum in there? No, that's not it. Okay, now the next one. Does it have a minimum on the interval 2 pi over 3 to pi? 2 pi over 3 to pi. No, it has a maximum there, not a minimum. Next one says it has a relative maximum on the interval pi over 3 to 2 pi, pi over 3 to 2 pi. Nope. 2 pi over 3. No, it does not have a maximum there. And then we look here at the next one. They said the graph has a relative maximum on 2 pi over 3 to pi, 2 pi over 3 to pi. Yes, it does have a maximum. So that's that. Now, again, they're trying to give us like some little shortcuts up here, I think, to try to help us out. But honestly, I think if you get comfortable with this, that's going to be your easiest bet. Okay. All right, y'all, for this video, we are done, but I need you guys to make sure that you watch the next one because we got to talk about actually calculating the average rate of change and all that jazz. Okay, that should be our last one for the whole section. I'll see you there. Bye.